Okay, ma. And the weight, what is weight, ma? Weight is related with the acceleration due to gravity, with the acceleration. Okay, ma. So this is the difference. So we can calculate the what apparent weight. Apparent weight. What is apparent weight? Is the weight of the body occurred due to the action of gravity and the other external forces acting. Okay, wow, that is called the apparent weight. That is varies from place to place. Okay, wow, variation of acceleration due to gravity. Next, geometric radius. G is the geometric radius of the Earth. So G is proportional to 1 by r squared is the apparent weight. So G is maximum at the polar region, minimum at the equatorial region. So weight W is equal to mg. G is the various. G varies. The weight of the body is more at the poles and the equatorial region. Okay, when we move to the higher altitude from the surface of the Earth, the value of G reduces, and then we move deep below the surface of the Earth. Also, G reduces. Okay, so this was the last lesson. Next, now we go to the rocket propulsion. How the rocket launched, ma? How the rocket was? So many rockets launched. Okay, what is the principle for the rocket movement? First of all, the rocket will be sent through in straight line. Okay, and then so Newton's third law is applied in the rocket propulsion. Okay, what is the third law? What is the third law for that? For an action, for an each and every action, there is an opposite reaction. Okay, like that, rocket filled with the fuel. Fuel, there may be liquid or solid in the propellant tank. Propellant tank means container. Propellant tank. When the rocket was fired, the fuel was burnt and the hot gas ejected with the high speed from the nozzle of the rocket. Okay, that produced a huge momentum. Huge momentum. What means huge momentum? Momentum means a linear motion that will go in straight line. The rocket will go in straight line. That produces the velocity. Mass into velocity is equal to momentum. So that produce the huge momentum. Understand that? Huge momentum. And then next thing, to balance this according to that, how much of momentum will produced, that much of pushing action will be calculated. Okay, pushing action, an equal and opposite reaction force is produced the combustion chamber. Okay, so what makes which makes the rocket project forward? Yeah, that push forward the rocket. Yeah, the huge momentum project due the force. Here the force means how push the rocket forward. Okay, while in motion, the mass of the rocket gradually decreases because the mass of the fuel burnt. The mass of the fuel burnt until the fuel completely burn out. Okay, so mass decreases, the momentum will be increases. The momentum will be increases. There is no net external force acting on it. Okay, the linear momentum of the system is conserved. Okay, so the linear momentum, the mass of the rocket decreases with altitude. Altitude means high altitude, which results in the gradual increase in velocity of the rocket. Velocity of the rocket also increases. So what are the forces? Push or pull force mean linear motion, and then Newton's third law was applied for the rocket propulsion. Last stage, it reaches the velocity completed when it is sufficient to just escape. When they escape gravitational pull of the earth, when the gravitational pull of the earth will be zero, the rocket will be left, reach the velocity. Oh, this velocity is called the escape velocity. Okay, this velocity is called the escape velocity. Next, weightlessness. What is weightlessness? Weightlessness now. What now you see that? What do you see in this picture, ma? Roller coaster. Okay, roller coaster. In the roller coaster, when we go upwards and then come downwards. what will happen? We feel the weight freely. Okay, weight freely. Weight, our weight will be less. Why? Because of the momentum. Because of that momentum. So in the roller coaster, okay, we act feel freely because weightlessness. Okay, we have lost our weight. We move down with a certain acceleration. What is the acceleration? Acceleration means change in velocity divided by time. Okay, that we experience in the same drawing the lift also. When the lift move up, move down, acceleration equal to the acceleration due to gravity. Lift also. Lift, and then A is equal to, at the time A is equal to Z. A means acceleration is equal to the G. G means gravitational force. Gravitational force means acceleration due to gravity is equal to the A. So the motion is, we will be freely, our weight will be very less. That is called the free fall. That is called the free fall. Here the apparent weight. So what is the apparent weight? R is the apparent weight means R. R the reaction force exerted by the lift surface. Reaction force. Reaction force means what? Reaction, what is, we go in the lift. That is the reaction. Reaction force exerted by the lift surface, that is equal to R. R is equal to apparent weight. R is equal to apparent weight. R is equal to M. G minus G is equal to 0. Okay, so of the person, the apparent weight will be 0. The condition state refer to the state of weightlessness. Okay, so now we go to that. Here, you see in that. What is that? An astronaut. The astronaut is on the space. What he feel his weight freely. He feel his weight freely. His weight will be very less on space. Already we learned the last class. Gravitational force 0.1625 only on the space. So in the on the Earth 9.8 acceleration due to gravity. So 10 times more than on Earth. In the space 10 times less. Okay, so the astronaut will feel freely. There is no gravitational force actually. So many people told that there is no acceleration gravity. No, that is not. That is how the orbital velocity. Okay, so that same effect takes place will falling freely in the roller coaster or swing and the vertical giant wheel also. Okay, we feel an apparent weight loss and weight gain when we are moving up and down in such ways. Understand? This is the reason for the weightlessness. Okay, now yes, apparent weight in lift. Done. In the first one, what is the first one? The lift is moving upwards. Okay, with an acceleration A. With an acceleration A. So R minus W, weightless, is equal to F network, net force. Net means net force is equal to MA. M is the mass of the body, A is the acceleration. Okay, R is equal to W plus MA. So R is equal to mg plus ma. Okay, R is equal to mg plus a. Mg plus a. So R is greater than W. What is greater than W? Weight. R when the resultant force is greater than W. Apparent weight is greater than the actual weight. When the lift is moving upwards. Moving upwards, we feel the weight. We feel our weight fully. Okay, lift is moving downwards. What will happen? W minus R. W minus R. Weight by W minus R. Here, case 1, lift is moving upwards on the R minus V. Here, R minus W minus R. Okay, so F net equal to R is equal to W plus minus MA. So mg minus ma. like mg minus a, r is less than w. R is less than w. Okay, apparent weight is less than weight. So lesser than the actual weight when the lift is moving downwards. Okay, here next upon lift is at rest. Lift is at rest. Here the acceleration is 0. Acceleration is 0. A is equal to 0. R is equal to W. R is equal to W. R is equal to mg. R is equal to mg. Okay, m is the mass of the body, g gravitational force. So R is equal to W. So apparent weight is equal to the actual weight when the lift is at rest. We feel our weight freely. Okay, next one. Lift is falling down freely. Lift is falling down. So where the acceleration is equal to the g. Acceleration வந்து g க்கு equal ஆகுது. A is equal to g. R is equal to m g minus g. So R is equal to 0. R is equal to 0. Falling freely. Falling down freely. Okay, and then the first upon we saw one picture. Rolling coaster also falling down freely. Okay, here R is equal to apparent weight is equal to 0. So apparent weight is equal to 0. So do you understand this apparent weight? How is in the lift is moving upwards? Moving upwards, the apparent weight is greater. Okay, moving downward, apparent weight less. Okay, next one, the apparent weight is equal to the actual weight. Next, lift is falling down, apparent weight is equal to the 0. Okay, this is the reason for that apparent weight. Yes. Yes. Next, weightless of the astronauts. Okay, some of them believe that astronauts in the orbiting of the space station do not experience any gravitational force. There is so many people told that have no gravitational force on the Earth. So they float. But this is wrong. Okay, astronauts are not floating, but they falling freely around the Earth. Falling freely around because the weight will be free. Okay, due to this huge orbital velocity. Huge orbital velocity and then apparent weight. His apparent weight also free falling. Okay, next one. Since space station and the astronauts have equal acceleration, they are under free fall condition. Okay, since space station and astronauts have equal acceleration. Equal means already in the case 4B1 now only we saw that. Okay, R is equal to 0. R is equal to 0. Apparent weight is equal to 0. So free fall condition. They are in free fall conditions. Okay, the astronauts and the space station are in the state of weightlessness. So they are in astronauts also and then space station also. R is equal to 0 because they are in the state of weightlessness. Understand? Next one. Now applications of Newton's law of gravitation. First one, dimensions. What are the dimensions? For dimensions means measurements. Dimensions means measurement. First upon massing of the earth, radius, mass of the earth, radius of the earth, acceleration due to gravity. Okay, and then the acceleration due to gravity. Next, Newton law of gravitation, gravitational force. These and all measured by the gravitational law. By this gravitational. Okay, so diamond applications for the applications means what is the application? Application means they are useful for the Newton's law of gravitation. Okay, dimensions of the heavenly bodies can be measured using the gravitational law. Mass of the earth, radius of the earth, acceleration due to gravity, etc. can be calculated with a higher accuracy. Okay, help in discovering new stars and planets. Helps in discovering new stars and planets. Okay, helps in the new planets and the stars. Now itself, new planets will be discovered by the Newton law of gravitation. Next, wobble. What is called wobble means the stars are moving here and there. They will collide with the planets. That is called the wobble. Okay, That is called the nearby planet. Okay, the irregularities in the motion of the stars. Okay, irregularities in the motion of the stars is called oval. Lead to the disturbance in the motion of the planet nearby. Okay, in this condition, the mass of the star can be calculated. Mass of the star can be using the law of gravitation. Using the law of gravitation. Okay, helps to explain germination of roots. Germination of roots is due to the property of geotropism. What is geotropism? Already we know about how the seed germinate. Seed germinate and then root. Root grow into the earth, into the soil. Okay, and then root. That is shoot system. That is root system. The upper plant is called the shoot system. Yeah. Due to the geotropism, the property of the root can be calculated and explained by the Newton's law of gravitation. Okay, so which is the property of the root responding to the gravity. Okay, helps to predict the path of the astronomical bodies. Okay, where the astronomical bodies are predicted. Path means what? Where they are surrounding the sun. Okay, like the planet bodies, astronomical bodies can be calculated by the Newton's law of gravitation. Understand? Yes, the lesson is over, ma. Now I want to recall some laws. Okay, I think that Newton third law, second law, first law. Already I gave one question, long answer. Newton's law of motion. Only 3 laws want to write, but some of them only return the test, others not written. Okay, now I explain again. After that, after this session, you write and send the 2 long answers. First one is state and prove the conservation of momentum, and then Newton law of motion. Okay, now okay, first law already you know that is very easy only. Already we have written that there are so many things around us, but they'll not move. Okay, we give push or pull any force on that, only that will move. That is the first law. Newton's second law. What is the Newton's second law? The force acting on the body, how much of force we give on the body, that is directly proportional to the rate of the change of linear momentum of the body, and the change in momentum takes place in the direction of the force. Understand this? That for force acting on your body directly proportional to the rate of the linear momentum. Already we will derive the linear momentum. What is the linear momentum? P is equal to mv. P is equal to mv. P is equal to m mass into velocity. Okay, change in momentum takes place in the direction of the force. This is the law. Okay, this is the law. And then this derivation of the Newton's law. Derivations of the Newton's law. Okay, first upon, now this law helps to measure the amount of force. Okay, it is also called the law of force. Okay, mv the mass of the moving body, u initial speed, next t time period, v is the velocity of the body changes. Now we calculate that F is the unbalanced external force. Your initial momentum of the body, Pi is equal to mu. P is the momentum. I means initial speed. So initial momentum is equal to mu. Final momentum Pf is equal to mv. Change in momentum delta. Delta means small triangle. That triangle indicates the change. Okay, change in momentum delta P is equal to Pf minus Pi. Okay, so is equal to mv minus mu. Okay, next by Newton's second law of motion, F is proportional to rate of change of momentum. Okay, change of momentum divided by time. Yeah, mv minus mu by t. So next step, F is equal to Km V minus U by T. Km V minus U by T. K is the proportionality constant. So that is negligible. That is negligible. So M V minus U by T. K1 in all the systems of unit. F is equal to M V minus U by T. Since acceleration is equal to change in velocity by time. So what is acceleration? Acceleration is change in velocity. Velocity means initial velocity, final velocity. Final velocity minus initial velocity is called the change in velocity by time. V minus U by T. So hence we have F is equal to M into A. So force is equal to mass into acceleration. This is the Newton's second law. And then we go to the Newton's third law. What is the Newton's third law? What is the Newton's impulse? That is Newton's third law means for every action there is an equal and opposite reaction. They always act on two different bodies. So if A applies a force FA, force FA, body A, force FA on body B. The body B react with force FB on the body A, which is equal to the FA in magnitude but opposite in direction. What is the example for that? FB is equal to minus FA. Minus means minus indicate the opposite reaction. Bird fly, swimming, gun, like this. When a man fire the gun, the bullet go towards the opposite direction, towards the direction, and then his hands will pull backward. That is the opposite reaction. Yes, that like that. Next, conservation of momentum. What is the conservation of momentum? Already we know that A and B. M1 is the mass of A, M2 is the mass of B. Next, what is the initial velocity? Initial velocity, final velocity. Initial velocity U1, final velocity U2. When U1 and U2 is the initial velocity, V1 and V2 is the final velocity. So A give force on B, B give force on A. So FA is equal to minus FB. Understand? FA means force of A is equal to the minus opposite force. B give force on A. So that is negative. So by the Newton's third law of motion, action force is equal to the reaction force. So now we write M1 V1 minus U1 by T is equal to minus M2 V2 minus U2 by T. So M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2. So this equation comes, what is that? What is it? Do you understand that is M1 multiplied by with V1 minus U1, and then M2 multiplied with the V2 minus U2. Understand? So then only we write the next equation M1 V1 and then M2 V2 is equal to the M1 U1 plus M2 U2. That is, the final velocity is equal to the initial velocity. So the above equation confirms that in the absence of external force, the algebraic sum of the momentum before collision equal to the initial collision. Before after collision is numerically equal to the algebraic sum of the momentum before collision. Before collision and after collision will be same. This is the conservation of momentum. There is no change in the linear momentum of the system of the bodies as long as no net external force acts on them. This is also one of the derivation, one of the definition for the law of conservation of momentum. Both are equal only. Next, gravitation, universal law of gravitation. Last session only we saw that. What is that? So many things on the earth. All the things are attracted towards the earth. That is, we know that according to the gravitational force. Due to gravitational gravitational force, acceleration due to gravity. And then also another one thing, each and every particle attracted one another. That is the universal law of gravitation. Understand that this law. What is the force? The force is directly proportional to the product of their masses. We know that. What is the proportional? Inversely proportional. Proportional means what? The mass is more, the force will be more. The mass is less, the force will be less. This is proportional. That is inversely proportional. What is inversely proportional? The mass is more, the attractive force is less. This is less, that is more. That is inversely proportional. That is inversely proportional to the force is inversely proportional to the distance between the center of the bodies. Understand? Yes. Okay, ma. So this is the center of this body. This is the universal gravitational law. Yeah, this law states again. Once again, I read out that this law states that every particle of matter in this universe, every body or particle, okay, ma, attract every other particle with the force. Understand? This force is directly proportional to the product of their masses and inversely proportional to the square of the distance between the center of the force of the masses. So the direction of the forces act along the line joining the masses. Now the derivation what m1 and m2, the masses, two bodies attracted towards the distance r meter. R in meter, small r indicate the distance. Okay, what? Small r represents the meter, represents in meter, that give the distance between the A and B bodies. So F is proportional to M1 into M2. Okay, that is proportional. F is inversely proportional to R squared. R squared. So that has written 1 by R squared. Next equation. Okay, combining these two expressions, F is proportional to M1 into M2 by R squared. Okay, M1, M2 R squared. Understand? M1 into M2 R squared. Now, G is the universal gravitational constant. G is the universal gravitational constant. The G is the capital G is the representation of that is represented, the universal gravitational constant represented by the symbol G. Understand? So there we can calculate that. This is the constant value. This is the constant value. So 6.674. SI unit is 6.674 into 10 power minus 11 Newton meter squared kilogram minus squared. Okay, Newton means force. Meter is distance. Kilogram is the mass. Kilogram is the mass.